this time of the year, IFA 2015, live from Berlin. Here we are in the Hall 16 here at the Intel booth. We are now about 10 minutes behind. I thought we could kind of catch up with the previous guest, but there was just no chance after talking about all these products. And of course, you guys also had some questions. I'm very, very excited to talk to someone who, in my opinion, gave one of the most interesting presentations during the Intel Developers Forum just some 2 weeks ago. And this is Shlomit Weiss. She's the Director of Engineering for the design of the client products. Good morning.
Good morning.
Welcome to Berlin. Is this your first IFA?
Yes.
How do you like it so far?
First time in Berlin even.
Oh, there you go. You know, the weather is great.
Excellent.
You can enjoy the city. You can enjoy one of the most interesting consumer electronic shows, right? And you should do that.
Yeah, very, very exciting place.
So, Shlomit, IDF just happened two weeks ago. Just to give our viewers an idea, what are you doing at Intel? What is the director of the design doing for the clients? What's happening in your lab, in your office?
So I'm not in my office, actually, most of the time. I have a team of about 700 people that is spread between Israel and the US, and part of the team was in India also, that we work on Skylake. And we are actually taking all the steps from the definition phase, implementation, verifying the silicon until it's ready. And today we release the baby out to the world.
So just to wrap it up, we basically have the godmother of Skylake sitting in our studio over here, being responsible for this amazing silicon. You came a long way with Skylake. This was a little bit of a game changer if we're looking back at the other Core generations, right?
Yeah, actually it was a very interesting product, and in a different way, a very challenging product as well. We had a relative large redirection in the middle of execution. And when the redirection came, it was, you need to be really, really low power, but don't give up anything on performance, which we know it's a big challenge. Some people were skeptical, is it possible or not? But really, this is motivation for engineers. We'll prove them wrong. And I think we did, because we have very good performance in a very low power envelope.
Switching over to 40 nanometers right now for you guys, that was, of course, also a huge advantage coming from, what was the last one, 22, right, or 20?
22 was the
22.
previous process.
Yeah.
Skylake is 40 nanometer, so we are using the goodness of the process itself, and we changed the architecture and microarchitecture to get to where we are.
So we've talked about this already with Christian Lamprechter before to show a little bit about the advantages of Skylake and its unique specifications. We were talking about scalability. I mean, to see that you guys are delivering a silicon right now that scales from 4.5 watt to like 75 watt, or even more.
91. So it's 4.5 watts to 91 watts, about 20x in the power envelope. We can look at a different dimension on the package size.
Oh,
so
yeah.
I happen to have
we have some demos.
I don't know if you guys can see it, but this is the 91 watts. I don't know which direction it goes. This is the 91 watts, which are pretty...
Yeah, we have a little mobile cameras.
So we'll do it this way.
There we go.
And the 4.5 watts, I will hide it. It's the size of 2 euro cents. But if I drop the 2 euro cents, this is actually the 4.5 watts part, or Core M, basically, family. So side by side, maybe that's the weight.
Oh, don't drop it. That was the gravitation test. I'm glad that we still have gravitation here.
So this is the side by side. I don't know.
That is amazing. So just to give you an idea, once again, so this is the Core M Skylake architecture, and this would be probably, or it was like a Core i7.
It's a
Xeon.
Yeah, it's i7, not Xeon. It's an i7 S family from the desktop.
Okay.
Core desktop Skylake as well.
That is amazing.
And if we can look at the Core M, it actually has 2 chips in the die. It's 2 different dies in the package. One is the SoC, one is the chipset. All in this small size. So it is very scalable.
Once again, you've never had anything like this in your portfolio, and just to give our viewers a little bit of an idea, I mean, this is not a product that you can come up with in like 1 or 2 years, because it was a radical change of architecture for you, right? To make this happen. So how long is this process, this development process of finally, going to your CEO and saying, you know what? I think we can show it now.
So the overall, in terms of time, it's about 4 years or so, but it has different stages. We start from getting a definition, which basically we are told we would like this power, we would like this kind of gaming to work, and so on. We need to translate this definition into what are the architecture that is needed or microarchitecture. Then it goes to the design phase. We do what we call the tape-in, which is first time to manufacturing. We get silicon back, and it is going through thorough testing to make sure functionality is okay, we are meeting all the parameters, the power envelopes, and so on. And only then we say it's ready to go out, and we are happily celebrating in such an event.
When you, also to explain this a little bit, I mean, those processes that are happening after the silicon is ready and you figured everything out, before it really gets into the product, before you really go into announce, I'm pretty sure there's a lot of quality management going on internally.
Right. We have a lot of testing, and the testing is covering all the aspects of a product. When I say all the aspects, it means functional validation, it means the power envelopes, it means the frequency, it means the strength, meaning duration of stress. We are doing massive stressing to know that when it goes outside, it will be stable enough for the different environment and builds that it will go through.
So I know that you have, I think is it in Santa Clara, your little benchmarking group? Oh, maybe I'm mixing it up.
They are spread, it's not only in Santa Clara.
Those guys that are getting locked up, right, and constantly have to run all the latest stress tests and benchmarking it next to the competitors, right, so that your product managers can prep the slides for the presentation and they're not getting proved wrong by the press and the reviewers afterwards and by the competitors. So everything needs to be very tight and right, it just needs to be perfect, basically.
We are an engineering company, so everything needs to have the quality of all the measurements. So all the numbers that we quote here, it's something that was carefully measured, approved that this is the right measurement or comparison or system that we can use it for. Yes, of course.
What I think is very, very exciting to see how Intel changed in the last couple of years, let's say in the last 5 or 6 years, especially when it comes to create those low power consumption platforms. For me, it was like, when you look at this development, we had Intel high up here because of the sheer performance of the platforms, but they also needed a little bit of power, right? And now you had to kind of waterfall down the performance and the features and the richness of your silicons into very, very mobile platforms. And the Core M that you are showcasing here, this is something that goes into tablet computers, right?
It can go also, but we need to be very careful. We didn't really gave up feature or goodness for the low power.
Right.
In Skylake or 6th generation, we have many techniques where we save power in a more efficient way. Mm-hmm. We are not really giving up the goodness or the functionality.
Right.
One concept of saving efficient way is making sure that only the transistor that really need to work for a specific function will be powered on, and everything else is quiet. It's not using the power.
Yeah.
So it's design techniques and architecture and microarchitecture together that make it possible.
And also to give to talk about this 4.5 watt Core M, this is also meant to be in fanless devices,
yes,
right?
Yes, the 4.5 is for fanless devices. Yes, and we actually have in our labs fanless that we share, and we actually had a demo in a lab system not a build one, mini lab system, but 4.5 fanless, showing at the same time a movie high definition and a game that you can play. And you can touch the part. It's not more than 4.5 watt. Actually, we gave a test. Who is brave enough to touch?
And they didn't burn themselves.
Not at all.
So what's the biggest challenge for you guys from an engineering point of view to, I mean, God, I remember like 10 or 15 years ago, we were talking about like sheer physical limitations in terms of processor design, right? And then we went into multi-cores. Right, and now we have so the kind of three-dimensional architectures. Are there any limits in terms of imagination of where you can go? I'm pretty sure there are none of them. But aren't we reaching a kind of point where say, you know what? No, it's going to be a little bit more challenging for us.
So I think it is challenging, but I think every limit is driving a new innovation. And in my mind, engineering, it's like an art. You find the limitation, and now let's see how we solve it. Have an innovation for it, break it, go to the next limitation, solve it also, and so on. A very big challenge when you have those limitations is to do the right trade-off. So in Skylake, I think in many cases it was an art of trade-offs between how we balance power, performance, cost, area, schedule, resources, everything together. But this is how we overcome difficulties, challenges, by doing this innovation and balancing trade-offs.
By building such highly integrated chipsets that we have right now here, and what you were showing, what you're putting into the package of the Core M, this is truly amazing. It's not only about Skylake, right? What Intel to see that whole portfolio. I mean, already the new portfolio already started during Mobile World Congress when you were showing the latest generation of the Intel Atom processor, and what I thought was one of the most exciting demos during IDF was to put Curie into the handlebars of the BMX bicycles, and once again this. I'm not sure. It's mainly because of the new CEO. He seems to be very, very geeky, right? And he just loves all these little what is possible with our devices, with our products, and let's try out things. Can you also feel that there's something changed inside of Intel, that it's a little, I wouldn't say a different approach, because you still want to build the best silicon that is out there, but that the company opened itself up a little bit to the developers, to the consumers, to show, you know what, we can even go beyond what we did before.
Yeah, I think it's an extension kind of what Intel is. And the extension is by the fact that it's more about the experience. Mm-hmm. After we know what the experience we want to get to, then we go back, if you want, and translate how to get there, how to build it to get to the experience. But the experience, the developer, what you see, how you feel, what you touch, this is the starting point, or this is what's driving where we go in the different directions.
And once again, if you guys have any questions towards Shlomit, towards engineering of the fastest processors that are out there, the fastest processors going into our future laptops and desktop system. I know a lot of people that are interested in gaming are watching us right now, and this is why the announcement at Gamescom like 4 weeks ago for Intel was, of course, also huge when they were showing their latest overclockable versions of the Skylake already. Was it 6670K? Oh, I'm so bad with this product. It's serious numbers.
67K. So if we talk gaming, maybe we want to mention there is an overclocking system in mobile. First time in the Skylake family. So for those gamers, they can enjoy the mobile system as well with overclocking.
There we go. So guys, if you're looking for a new mobile gaming platform, a new gaming laptop, right, the next generation that is coming out from the OEMs, you will see, I'm pretty sure, like those, what you would see from Asus, from Acer, MSI, huge in gaming laptops. I'm pretty sure that Alienware will also have something in their portfolio. So this is going to be quite interesting. What's important for the design of Intel products? This one question out of the chat: is there any fundamental philosophy, or is it just, you know what, just build the best processor, make sure that the performance per watt is killing all our competitors? What is it? Is there anything that you guys have in mind when you're creating the next generation?
So as I said, we are starting from the experience, also for our processor, not just for other stuff. And experience is how a person will enjoy it better, will use it better, how more efficient this can be. Taking this experience back into what is needed in the design to get there. So this is the main direction. Let's start from the experience. What's good? What's the experience we want to generate? And then we go back how to build it, of course, in an efficient way, cost-effective.
And by the way, guys, this also has a lot to do with market research, right?
Yes.
So they're doing a lot of testing with hundreds, with thousands of people, how they are using a computer, how they're interacting with it, what kind of, input devices they use.
Actually, we have a group of anthropologists at Intel that they are starting the beginning of the usage, right? They just watch people, how they use it. They come with all kinds of idea how they think it will be used 4 years from now, 5 years from now, and then it's translated really to us because we need different kind of definition to the product.
And there we go. This once again tells you a little bit about the development period of such silicon. When those anthropologists already doing their research for 4 or 5 years before they're starting to report, and then Shlomit and her team are going to work on the next generation chip for another 4 or 5 years. That is amazing.
And sometimes it's a challenge because it's very difficult to project so much ahead what will be the direction or the usage. And this is when we get this redirection in the middle, and we need to know to respond them.
Yeah. Shlomit, thank you so much. That was really, really interesting to see how that's going on. Congratulations for your new product and for your new baby over here. I think it wowed all of us to see. Once again, for me, I think it's just the scalability of it. I would have never expected anything like this to come out of your labs so soon. What you achieved with Skylabs, and whatever I hear from the enthusiasts that are out there, but also your OEMs, right? That can play around with it right now. There's quite exciting momentum in the industry right now due to Skylake. So thank you so much. Make sure that you're going to enjoy Berlin. Make sure that you hit the show. And you know what? Try to get out of the bubble at IFA, because you know what I did at the halls 1 to 4, 1 to 5. It has nothing to do with IT anymore, right? Those are the halls where I never went. Whenever I got into the IT halls, I just rushed through them. But you know what? When we're talking about Internet of Things, when we're talking about the connected home and all of this, I mean, this is not a buzzword. I saw my first connected home from Microsoft 15 years ago, right? And it was already pretty cool. But what those appliance manufacturers are building right now is absolutely amazing. And I got so into it, right? I just love to see it. And they have amazing cooking shows with some star cooks over here. So if you guys have a chance to come over here to IFA, make sure to check out the whole show. It's quite interesting. Once again, thank you so much. And also for showcasing us the products. We're going to have a little bit of a break. And then it's going to be 11. And when I look at my timetable, it says to be announced. That means maybe we're ending up with like having a little chat between you and me for the next 30 minutes. I'm just getting Nicole in here or Chippy. We're going to find a solution for this. We're going to have a short break, and then we're going to be back right away.
Thank you very much.
Thank you so much.